This answer is wrong because by saying that ionic compound conducts electricity in molten state. If you look at the table properly, you notice that for C, it also conducts electricity in molten state. Okay, actually a metal also conducts electricity in molten state. So you have to be specific. So you have to say because ionic compound conducts electricity in molten state only when all its ions are mobile. Okay, just to add in only, because this question doesn't differentiate ionic compound with metal. But this answer, the second answer, does differentiate ionic compound and metal, because metal not only conduct electricity in molten state, it also conduct electricity in solid state. Okay, so make sure your answer is specific. After writing down your answer, you have to read it again, make sure it is specific. Alright. Hydrogen chloride gas does not conduct electricity. An aqueous solution of hydrogen chloride does conduct electricity. Explain why hydrogen chloride behaves differently as a gas and as an aqueous solution. So for this question, obviously you have to explain what happened to hydrogen chloride when it is in the form of gas and also as an aqueous solution. What happened to them? So a lot of students tend to write like this: in aqueous solution, ions are free to move, hence conduct electricity. But this answer does not address hydrogen chloride in gaseous form. So instead you have to say, in aqueous solution, hydrogen chloride exists in mobile ions, hence conduct electricity. In gas, hydrogen chloride exists in molecules. There is no free ions to conduct electricity. Okay, so it addresses both hydrogen chloride in gas and in aqueous solution. Explain why compound B does not conduct electricity when solid but conducts when molten. Compound B, which is an ionic compound. Okay, and then again, a lot of students tend to write this: when in solid, the electrostatic forces of attraction are strong and hold the ions in fixed position, hence no mobile electrons to conduct electricity. Fine. When molten, the electrostatic attraction forces become weaker and ions are free to move around to conduct electricity. Actually, the whole thing is fine, except that the electrostatic forces of attraction does not become weaker when the compound dissolves in water. Okay, the strength of electrostatic forces of attraction doesn't change. Okay, very important misconception. So instead, you should not mention the change of strength of electrostatic forces of attraction, because it doesn't change at all. So you have to say, when it is a solid, okay, they are held in fixed position, no free ions to conduct electricity. When molten, the ions are free to move around to conduct electricity. So what happens is, when molten, when it needs to be melted, heat needs to be supplied. So the heat actually overcomes the strong electrostatic forces of attraction, and hence breaking the attraction, overcoming the attraction, and the ions are free to move about. Not because the electrostatic forces of attraction becomes weaker. Okay, very important. The next one: which compound A or B has a higher melting point? Explain the difference in their melting point. And when you talk about melting point, a lot of people just say, oh, it's because it is an ionic compound, it has high melting point. Or worse, a lot of people say, oh, ions in compound B are held by strong intermolecular forces. There is no intermolecular forces in ionic compound. Okay, and instead you should say compound B, the ions in compound B are held by strong electrostatic forces of attraction. A lot of energy is needed. Okay, let's continue in our next video.